I'm going to ask you, Andy, to sort of introduce yourself, what your context and what you've done, and then the whole thing about AI, whether it's in imaging and stuff like that, which I know your area of expertise, the whole thing about it is like the new thing, isn't it? The new kid on the block. But is it new? And things like, we can ask that and discuss this in the panel on where it'll be, because it can be both exciting and frightening as well. So whatever you don't cover in your talk, we're going to try and in the panel as well, and where it sits and stuff like that. Because even, what is AI would be like a good start at some stage, but and where it takes us. So Andy, over to you.
Thanks, Ian. It's a really great pleasure to be here and present to you guys. And seeing the session earlier, it was really nice to hear the patient experiences. Because as a radiologist, I'm pretty much locked away in sort of the dungeon of the hospital and not allowed out. I think it was only, I'm not quite sure how I was allowed out today. Very pale. So it's really nice to interact with patients. A little bit more. So I haven't got 20 dense slides of deep learning neural networks for you. Some of you might be disappointed. I've heard the pulmonary hypertension patients are the most informed patients. That's correct, yeah. But I'm a radiologist, so I'm going to mainly try and make this relate to imaging. But the themes in artificial intelligence are all can be applied to any area of medicine. So and also you may have questions at the end we can talk about. So imaging all started with Wilhelm Röntgen when he discovered X-ray, and this was an image of his wife's hand. She died quite young, I think, from radiation damage. So we've kind of moved forward a little bit from that, and now we can do very detailed imaging of your insides, the structural details inside the heart and the lungs. We can see so much structural information with CT scans that the donut. A very fast test that's very it's very easy for patients. It's very good for getting lots of information. Other tests, you'll have had echoes, and there's an MRI scan where we get really detailed information of how the heart's functioning. Here's the 4 chambers of the heart, and we can see how each chamber's functioning, the volume, the function, etc. So we really do get amazing information. And in the future, and what we're already able to do now is take all that information and then automatically analyze it and get lots of automatic quantitative information that can tell us really important things about what's happening inside the body. And I'll talk a lot more about that afterwards. We'll come back to that. But yeah, as Ian said, artificial intelligence is not new. People have been thinking about artificial intelligence and coming up with early models since the 1940s, when they started looking at the neurons and the way the neuron has multiple connections coming into it. So you can take multiple pieces of information and to try to make decisions. And in the 1980s, there was a rapid rise of automation in the engineering industry with various robots doing cool stuff. Very frustrated chess players back in the 1980s who got absolutely annihilated by machine learning models. But then it was since about 2010 that deep learning came in, which allows learning to occur at multiple layers, a layered approach where the learning can occur between all these different nodes, kind of relating to that neuron where multiple pieces of information can come into one of these nodes. Imagine each one of those as a neuron, and then you're basically creating an artificial brain. This is a really boring slide, but anyway, artificial intelligence relates to anything that is where a machine is replicating a human task. Machine learning, the definition of that, so it sort of sits, all these things sit inside, artificial intelligence is everything. Machine learning sits inside that. The way I've heard that best described is it's trying to make a prediction, but you don't know, you can't program all of the tasks individually. It needs to have a degree of learning to make those decisions. I just mentioned deep learning, and then generative AI is what you're all using when you're on ChatGPT, reading about various things, and which is a massive explosion in generative AI, which is really making a massive difference. So in radiology, we look at a lot of images, and these images actually have massive amounts of data inside them. They have many gigabytes of information. But what we do in radiology is, well, it depends on who it is, to be honest. But some people will literally crystallize it down to a single couple of words. So you'll have your whole CT scan with all of that information, and they'll just say, there's no pulmonary hypertension, or there's no pulmonary embolism, which I used to say this as a criticism, and to say, you know, there's all this information, but actually it's a real skill to be able to crystallize what is the most important thing. But at the same time, there's so much information in there that we can learn, and also it depends on the expertise of the person who's actually looking at that scan. So if they're coming from a very small hospital, they might not have seen many cases of pulmonary hypertension. So therefore, that's where we need to try to use things like artificial intelligence to make it more homogeneous, so that everybody gets a fair experience and gets the right diagnosis. So this is where we're going to deep dive into artificial intelligence now. Here we've got an image of a bird, and the machine learning is going to try and classify it, or we're going to train a model. We're going to input lots and lots of images of birds. Okay, we're going to do lots of birds, lots of sunsets, lots of dogs, and lots of cats. We're going to put all these images in, really diverse, different creatures, and then inside this learning, there's a little box that's going to strip over all through the images, and it's going to learn every little thing about that little box inside the image, and it's going to learn all the features. Oh, it looks a little bit like this. Oh, there's some whiskers there, or there's some this, and it learns everything about that, and it pulls it all together. And then when you ask it, what's this? It knows that this is a bird, for instance. So, and also that decision of it being a bird is also not fully explainable. The machine has just said, okay, you give it an image now, it says it's a bird. It doesn't really know. We don't really know how it's come to make that decision. So one thing that we quite favour and others favour is something called segmentation, where the output of the model is a drawing around the bird. So the output, when we feed it another bird, we're going to give it this bird here, and it beautifully segments it. We give it an eagle, and it segments it beautifully, and then we give it we think it's wanting it to be a bird. It's expecting a bird, but it's Taylor Swift. No relation. Hopefully there is a relation. I can find and earn some money. And then the model says it's a bird. So I'm going to turn it into. I'm going to draw it as a bird. The reason for explaining this is that what goes into the AI model is exactly what the AI model will know. And therefore, if you show it anything that's not seen before, it will not know how to deal with it. So the great challenge with AI is the whole challenge really is making sure that the input data accurately reflects the full range of the populations that you are dealing with and you need to use to make the decisions. And in healthcare, okay, I'll come on to that a little bit later in terms of the challenges there. So in terms of you're using ChatGPT to run your lives now, the way that works is by lots and lots of text data that's gone into it. And the great thing with text data is there's a lot of it out there online, obviously, as you know. So for instance, when it sees 3 words, the sky is, and maybe some context, it will know that the sky is blue. And it's learnt that over many things. So it learns the relationship between words, and it can predict what word's coming next, etc. And you'll all know how good that is. Now, this guy, Eric Topol, who's a very famous cardiologist in digital health, he said with AI, he said this a long time ago actually now, and some people said that radiologists by 2020, I think, would be out of a job. All radiologists would be out of a job, or should be out of a job because of AI, but we're still here. This guy said that radiologists could come out of the dark, out of where they live in the basement, they could come out of the dark, and what we need is more bonding and human communication. But he doesn't know radiologists, and this is not what you need. You do not need radiologists coming along. You need the likes of David Kiley and the iCandy, obviously, with Ian, looking after you. So, and radiologists will still be in the dark, and will still have work to do because AI shouldn't be autonomous, basically. But a great challenge, obviously, I think everybody in here knows, is the difficulty of diagnosing pulmonary hypertension and diagnosing it early. It remains a problem because of the presentation, non-specific presentation, difficult to diagnose. So this is where artificial intelligence hopefully can have a big impact to try and reduce the the delayed diagnosis. And we see it commonly that some forms of pulmonary hypertension can be missed, even at the stage where they've had a CT scan. But the stage of the CT scan, there's so many stages before that which would allow many more diagnoses to be made. So I think this is really the big area that we need to invest time into is trying to improve that early diagnosis. So if you're looking for the diagnosis of pulmonary hypertension, or you're looking for where's Wally, it's quite difficult. It takes time. It it takes time, and maybe it takes expertise as well. You really got to know what Wally looks like. So we'll come back to that. But AI can just find Wally straight away, because if the AI has been trained with enough Wallies to know what Wally looks like, AI can find Wally straight away. So potentially can find those features of pulmonary hypertension. And AI can then also do crazy stuff like make the image come to life, which I don't think is very relevant for healthcare. Anyway, so now this is what we will be looking at on a regular basis in radiology. We're looking at a CT scan, for instance. So here, I want you to just look at this CT scan. You've got to present this shortly to your consultant, and I just want you to look at it for a minute. This is an example of perception and the problems of seeing something and being satisfied. We'll come back to that. But one thing in radiology is, and also in other areas, is that we do a lot of manual work, a lot of manual drawings of structures. We draw around the heart many times. A consultant might spend half an hour just literally drawing around the structures of the heart, so we can get the accurate volume measurements. And the volume measurements are very important to make diagnoses, but also to follow patients up. So these are just some Tibetan monks. I don't really know why they're drawing anyway. And then we have, so this is the kind of drawings that we do, detailed drawings of the heart. So we know the volumes, the mass of the ventricle, the volume of the ventricle, deviation of the septum, all these kind of things are very important. And we end up being very tired, very staring at a screen, a lot of RSI. And then, so can AI help us? Can AI help us? And I think it can. So this is what we've been working on for quite a while now, is spending a lot of time doing a lot of hard work segmenting, drawing around all the structures in the heart, and particularly doing it in the diverse range of scans that we see and the diverse range of features. Because if you train a model in a place where you don't have lots of patients with pulmonary hypertension, the model will not work in pulmonary hypertension because the features are quite different. The ventricle is very dilated, there's hypertrophy, there's lots of differences. So now we're able to do that, and I work with some clever, these are the clever people. I'm a hobbyist in AI. These are the ones who actually know about AIs, Ali Reza Hokmabadi and Michael Sharkey, who we work with in Sheffield. And we're able then to take those scans where before the radiologist would have just looked at it and said, there's no pulmonary embolism or this, to being able to say, exactly the volumes of the different structures, the knowledge of the relationships between these things can also tell us the diagnosis for various diseases or the likelihood of diagnoses. It can turn something that's quite subjective experience, requires the right level of experience, to something that can provide the same diagnosis each time. So I think, and also doing that in conjunction with working with the doctor is the way that we will improve the healthcare. And then with MRI, we've done this a lot, and this is how the very small window of fame came. was through where we developed a biventricular segmentation model of cardiac MRI, which we've now running in the hospital for a few years, which has saved sort of many hours of work. So it has efficiency benefits for us, but also what we do find is if you do this, you use the AI segmentations, it's more accurate for saying if there's been a significant change. So if you've gone on to a treatment, you want to know, is my right ventricle improving on the treatment, which we'd like to know. The AI will allow us to be more accurate in those measurements, because trying to draw exactly around a structure is a very hard task manually, but a computer can do that very easily. So that's a clear benefit. And one piece of work we did was to just say, let's not tell the AI anything, and can the AI just identify itself the features? And interestingly, I suppose the first thing is to say, what does it find any features, and then it determines which features relate to pulmonary hypertension. So here it has actually, you guys may be aware, you've got the right ventricle is the bigger chamber here. You're looking at the short axis. Some of you may have seen this in the clinics, but the AI has worked out that the red blob at the end there is on the septum, and it's saying, I've learnt that the septum is deviating from pulmonary hypertension. But when you do unsupervised learning, that means you don't tell it anything. You don't tell it what the diagnosis is initially or anything. The AI can potentially learn things that you hadn't even thought of. So it's a way of doing exploratory research potentially in the future, unsupervised learning. So this is my colleague Samuel Abed, who's really trying to push us forwards in terms of once we've got those segmentations, how we can use these to improve what we do. So we make these segmentations, we get the volume measurements from all these chambers. We can then know what the normal thresholds are for these in terms of the different, there's large bodies of normative data out there. So we can say your ventricle is dilated. And then we can start to build the actual report. So you might be thinking, well, what's the point in us anymore? So all we need to do then is just press the button, next scan. No, it's not like that. Essentially, but what it can allow us to do is to build a provisional report that can then be authorised by the radiologist, and the context can be evaluated, because AI is not good enough to look at the full context yet. And this is the other part of work that Samir is doing called Miracle, where he's taking the reports, because all reports now go to patients, and some of these reports will not make any sense. I really don't think they'll make much sense. But with the kind of the advances in large language model, we can then summarize them, turn them into the right language, and then it makes, and also they can be sort of tailored to the right audiences. Even for different clinicians, it could be tailored to different levels of clinicians. But for patients, I think that's a big benefit. So hopefully that's a success. A lot of people complain about the MRI scans being too long, also too noisy, but I haven't got a solution for that. But too long. So the manufacturers are now introducing faster ways to scan. And for instance, with Sonic DL is the fast scan, so that's done in half the time. And it actually looks nicer in some images. We're evaluating this at the moment, and it looks like potentially we can reduce the MRI scan time by half, which is quite good because MRI scans are not great to tolerate. They're quite long, noisy, and not especially enjoyable. And I think some people have said that they prefer a right heart catheter, but you know, it's definitely moving in the right direction. Did anybody see Where's Wally? There's Wally. Extremely difficult. Okay, there he is. And then, did anybody see the gorilla? Has anyone seen the gorilla? So there is actually a gorilla in the image. So it's actually the left lung, which is your right-hand side. High up, there's a gorilla going like this. So. And there's also a famous video of people playing basketball and then a gorilla walking through, and nobody sees the gorilla walking through. Because, and that happens to us in radiology, that we see this there's a lung nodule on the other side, we see that, we're really happy, we found a lung nodule, yes. We write it down, and then we don't see the gorilla. Gorilla's not really a recognised pathology, but it's a perception. It happens all the time. People will miss the second thing that was on the image, and then it's... and that's a problem. Whereas the AI would definitely have seen the gorilla. It would definitely have seen the gorilla. This is just some of the things for the future. Eye tracking is one thing. We'll be able to wear glasses and we'll be able to see where we're actually looking in the image. The only problem is if the managers know that we're not looking at the screen, that wouldn't be very good. Or if we start playing video games or something. The future might involve virtual reality. And the virtual reality headsets are improving because I feel very sick with those ones. And this is actually the new resident that we've got, who looks remarkably like someone from Star Trek, I think. And then I'm really, really keen on the idea, and David Kiley is as well. And some of you might know David. He's a really inspirational guy, and we're really keen on the idea of that information that happens at the referral point when you maybe have had some tests at the local hospital and they're wondering, what to do. That information really, really holds the key to whether the patient should be referred, how urgently, We're keen on that. But in this example, what we did was we went into the virtual reality world, and we put on our headsets, goggles in the middle of this presentation. We went into a world where we had a room where we had all the information for the patients. We had the medical records. David presented the case. We had their information, the pulmonary function tests and everything. There was a CT scan. We'd segmented the CT scan, so inside the virtual room we could actually look inside. It's a bit creepy actually. We could look inside the body. You could pull out the heart and if it doesn't hurt, it's all in virtual reality. And then there's a short video which is really hard to hear and it's terribly noisy. So maybe just close your ears if you don't like it.
I'm just going to grab. So this one here, David, is the right ventricular right artery. It's a little bit heavy.
It is. I can feel that. Can you feel that? It's a little bit heavy, and so when I look at it, I can see that there's some hypertrophy of the outflow tract. It's a very important feature in pulmonary hypertension.
Yeah, it's quite chunky.
So I'm going to have to go to the gym a little bit more often to lift the right vegetables.
So you get an example of where we might go in the future. But like I said, I feel very sick when I used to use those headsets. But there is potential there potentially to have everything, all the information in one place, so we can see all the information from the patients. Also, experts from around the world could potentially come and join us and teach us something about that. Or for education, you could come and observe what happens in an MDT. There's some things that have surprised me and are, it's definitely not all great, and we do need to be mindful. One thing which maybe, I don't know how relevant it is to this audience, but there was in the early stages of AI, a vendor came to me and said, we've just got a new solution on chest x-ray. We can take the chest x-ray and we can tell you what the echocardiography ejection fraction is to the nearest 1%, which is absolutely ludicrous. What I don't like is when people try and use AI to try to do something that's not possible. AI is not magical. It will do amazing things that make sense, but it has to pass a making sense test. And some things don't. But I think it is moving in a direction where AI will be very explainable and safe. So it's just along the way, we just have to be cautious. And what we found, and this is also improving, but some time ago we did this review and we looked at, with some of my colleagues, we looked at the limitations of the studies that were done in artificial intelligence in imaging. And very few of the studies had good clinical characteristics. So the patients their information wasn't represented in the study. They just had some images. So there's lots of images that are online of open source archives, but that doesn't give you enough information to say whether a tool is working properly. And it reflects that a lot of the work is done by groups who aren't working with pulmonary hypertension units. They don't know about the diseases. So that's something that needs to be improved. And a lot of the time, people struggle to access good data sets, and go beyond just drawing around something to actually making a diagnosis that's going to be beneficial to patients. And we were told that we'd be out of a job in radiology, back then. But the scale of the development has moved much more in the text area with the language models. That is absolutely exploded. And this is a log rank scale. That's not the actual. This way, the discrepancy between what ChatGPT and different models have is compared to what we have in imaging, where we have for maybe thousands or maybe 1 million images. The scale is huge. That's why these models work so well and are having such an impact. And in radiology, we're struggling, and we still need to invest a lot of time in detailed labeling so that we can utilize smaller data sets to make it work well for patients. And quite correctly, that your data is stored behind firewalls. You can't have big tech just come and access millions of MRI scans, because you kind of want to know what's happening with it. But at the same time, my feeling is that, and you can correct me if I'm wrong, that you want to share the data appropriately to people to develop tools that actually, to make a difference to your diagnosis, etc. So it's a fine balance. And that kind of reflects this with these large models. You can already do amazing things. So a doctor can already potentially enhance their diagnostics with the models that are out there now. But those models are not secure. They are, if you send patient information up into a cloud, that's there it's all there information, and it could potentially be unpicked later. So we need to move to be able to house these large, amazing models in safe ways inside hospitals, and that landscape is moving very quickly, and I think it won't be long before amazing models can be utilised to improve how a doctor functions, how a nurse functions, how the whole hospital functions in the future. And I think over time we need to learn how to work with the AI in terms of our training, so that when we're learning with, like moving from Google Maps, from map reading to using Google Maps, we need to train people to still know how to map read, but so that they can become more efficient because they use Google Maps, and not de-skill. De-skilling is something that people worry about. So that's the end, really, guys. But AI will help us to detect pH earlier. I'm sure of that. It will help us to not miss things, which we all desperately want. And but doctors won't be replaced. Some things are irreplaceable. Others not, maybe. But so that's it, guys. Thank you very much.
Excellent. And before you sit down, because you were on telly, weren't you? You were on. It was on telly. It was on Panorama. I know, I was impressive, isn't it? We all thought it was Please 5 or something like that. But has anybody got a question? That's good. I'll come to you in a minute. Can I just ask the audience, because something you mentioned right at the end, Andy, is about data. So it's lots of, when you go to hospital, lots of things are done. And this thing about security and things like that, and you said, are you happy for people to use data? What are people's general feels about data? Are you generally happy that it gets used in the way that Andy says, or do you think people should ask for consent? And I know it's a broad statement, so if you're generally happy that it's used like Andy described, does that cause you, are you happy with that? Just put your hand up. And whether you got, yeah. Anybody got concerns about that? No, there we are. The people have spoken. I think it is this thing. I mean, one thing, well, can we get the microphone? Have you got the microphone yet? While that microphone gets there. What about security? Okay, Andy, about big data. I know you've done radiology, is fascinating that, but you know, we hear all the time that it's recent, really. It's not a throwaway comment that the Co-op, I couldn't order my lettuce because it got sort of, people went into it and the system failed and stuff like that. How secure are these big things, do you think? And you're a guy with a lot of experience in this sort of thing. Is it really secure? Could it be used for bad as well?
Yeah. Well, I mean, firstly, also just on sharing the data, I don't think that if data is used, it needs to have a clear purpose, and the sort of ethics committees need to approve that it's being used for that purpose. And also there is a national opt-out scheme, so that it's very well advertised. So if anybody doesn't feel comfortable sharing data, it's amazing how many people are aware of it and actually do opt out. So you can opt out of having research done, which is perfectly acceptable. In terms of the big data and the big models, they currently, they're so big. They're like, for instance, if we ChatGPT is amazing, but we can't use it because you can't use the full models because they're just open. They're in the cloud. We need things that are constrained so that if something does go wrong, it's just a sort of a local level, and then all we're left with is our standard practice. All we want really is the AI to be additive on top of our current practice, so it helps us, but without and then the worry in 20 years' time is that everybody forgets how to do anything because they're so.
I suppose it's a bit like learning to spell, isn't it? I'm dyslexic, so I mean, spell check's been amazing for me. But you know, when things are automatic, you could forget stuff, don't you? I think also we will come to your question. Also, not to forget what matters in healthcare is compassion and all the other stuff. It's not just the technical stuff. Your question.
Okay, thank you. Really interesting, and obviously there's loads of great stuff going on. I was just wondering, with where the technology is at the moment, how condition-specific does the analysis of the scan have to be? So do you have to put it in and say, please look for signs of pulmonary hypertension? Or are we yet, or will we at some point be at the point where you can just put in a scan and it will be sufficiently joined up with the work that many other research teams are doing in other conditions to be able to pull out any diagnosis? How much steering do we have to give it at this point?
Yeah, I think because of the discrepancy in the amount of data we have, most of the time, and most even the companies or the research groups, they're tackling one or two things. I mean, we have a vision to be broader, and we're a bit crazy. We're always drawing new structures to try to analyse. But then probably we'll only achieve maybe one modality, CT pulmonary angiogram, for instance, where we can try to get everything. But also the number of diseases is so diverse and the imaging features are actually incredibly diverse. That's why the progress is not fast. I don't see it as being fast in radiology. You know, subtle differences in the patterns in the lungs can reflect different conditions. So there's a lot of work to do, but we're definitely only at, you know, automatically detecting a few pathologies, I'd say, in one go.
Good. Okay, Andy, you can have a sit down because I'm going to use you this afternoon in the panel this afternoon. Can I have the panel? Have you got one more question while the panel's coming up? If you get that microphone there. If Alan, Wendy, Carl, and Rachel come and take a seat, and Andy, you might need to come back because you might need to answer this question. Sorry, just getting your steps in.
Andy, how long will it be before it's in all general hospitals? I ask this because a year before my diagnosis, I had a CT scan that was reported as normal. Pulmonary artery pressures were over 1,000 when I was actually diagnosed.
Yeah. Well, I mean, it's something that I'm passionately working on, and we've been working in the research space, and there's currently no. In order to actually make the difference, we do need to be able to take the technologies to patients, and that actually, unfortunately, means we need to commercialise in order to make it. Because you need to get the certifications, you need to have the clearances to use these technologies in patients. So that is something that we are looking into, is trying to take the experience that we've got from the largest centre with large volumes of imaging in patients, and then try to turn it into a commercial tool, which it can then be run, and then those can be missed, because it does happen. We see it in the MDT each week, and there's missed patients with chronic clots and missed pulmonary arterial hypertension, because for some reason and I think one thing is reflected is the scan quality is improved. So it used to the heart used to be very blurry, and we didn't even look at it in radiology. We just looked at the lungs. So everyone knew a lot about the lungs, and then the scan quality has advanced more rapidly than the radiologists' understanding. That is also catching up, but then it has to dissipate into all the local hospitals so that it can be diagnosed. But no, I mean these things can be diagnosed, and with us showing the image of Sharkey and Ali Reza, who've developed models that can detect the pulmonary hypertension by segmenting those structures, the pulmonary artery will be dilated, the right ventricular hypertrophy will be there, features that are commonly missed. And the chronic clots, which are extremely difficult to detect if you're not looking for them, should be automatically diagnosed. So how long is difficult to say, but I'm passionate that we can do it.
Excellent. Cheers.